Okay, let's dive right into this. Welcome to the Explainer. Today we are tackling a massive, kind of persistent point of confusion that's been swirling around the developer ecosystem. And honestly, it's time we clear it up once and for all. Our goal today is to rigorously dissect two completely different technological components, local logic and on-chain state. And then, as you'll see, show you exactly how they snap together to create actual physical hardware automation. Now, I want to hook right into this because this is the exact question sparking so much debate right now. Is SeedTreeDB an on-chain LIFO ledger? Well, the short, definitive answer is absolutely not. No way. Today, we're going to bust this myth wide open, unpack exactly what SeedTreeDB actually is, and then introduce you to the technology that literally does handle that LIFO ledger. Here's our roadmap for today. We'll start with the architectural mix-up. Look at SeedTreeDB as the local engine, move on to ERC7827 as the LIFO anchor, disambiguate the kernel versus the stack, check out the cheerbot as the physical switchboard, and finally, wrap it up by bridging the physical and digital worlds. All right, Section 1, the great architectural mix-up. You know, when we're dealing with dense terminology spanning both Web3, smart contracts, and localized IoT hardware, wires inevitably get crossed. It happens. Lately, developers have been mistakenly conflating the active local computational engine with the passive, globally anchored on-chain state. Basically, they're mixing up the car's local engine with the actual highway it drives on. So, let's kick off our dissection phase and separate these two entirely different layers. Section 2, SeedTreeDB, the local engine. So the crucial point is, what's the actual technical makeup of this system? Well, SeedTreeDB is a strictly localized, web-based engine rooted in the HSD, or Hierarchical Script Database patent. It's built entirely on Node.js and HTML. And its real superpower? It uses a JSON-like tree structure to unify static data, our nouns, and active computing logic, our verbs. It literally puts them right next to each other into single, seamless nodes right there within the application runtime. Now, to maintain perfect order inside that local database, SeedTree uses something called the syn kernel function. You can think of this as an uncompromising, super strict logical bouncer standing right at the door of your database. It sequentially checks to see if a database space is empty. That's the thesis. If it is, great. It synthesizes the new data directly into that open slot. But if data already exists, the bouncer firmly and violently rejects the input, the antithesis. It evaluates this logic before a single byte is ever written, which completely prevents those accidental overwrites and namespace collisions. And here is our definitive myth-busting reality check. Because SeedTreeDB is the active engine evaluating that syn logic locally, it is explicitly not a last-in, first-out, or LIFO stack. It does not handle the global state ledger, period. Moving on to Section 3, ERC7827, the LIFO anchor. Okay, so if SeedTreeDB isn't our on-chain LIFO ledger, what is? That would be ERC7827. But real quick, let's clearly define LIFO. Last in, first out is an architecture where the very last item to go in is always the first item to come out. Imagine a highly efficient ID checker at the front of a club line wrapping around the block. That checker doesn't need to scan the entire history of the line. They only need to look at the ID of the person standing directly in front of them right now to know the absolute current state. Which brings us to the core mechanisms of ERC7827. It takes standard, lightweight JSON and transforms it into a rigorous mathematical EVM, or Ethereum Virtual Machine, smart contract layer. It introduces value version control, and because of that LIFO architecture, the system only ever needs to query index 0 of the data tree. Just by checking that single top layer, you get an immediate, flawless mathematical proof of the system's absolute state. No guessing, zero ambiguity. The source documentation for this new standard absolutely does not mince words either. It says, the old upside-down tree is apostasy, a heresy that has to be purged to achieve true physical automation. Wow, why such strong language? Because the old event-driven data structures were floating, top-heavy, and totally chaotic. This new ERC7827 LIFO architecture provides a mathematically pure, grounded, root-to-leaf path that is strictly anchored in reality. Section 4, disambiguation, kernel versus stack. And this brilliantly illustrates the exact difference. Let's put these side by side. On the left, we've got SeedTreeDB. It's a local HTML and Node.js environment, utilizing the syn function to actively evaluate logic. On the right, we've got ERC7827. It's a global, EVM-based blockchain standard utilizing a LIFO stack to provide a passive, unalterable index zero ledger of the absolute state. Local active logic on the left, global passive truth on the right. Section 5. Cheerbot. The physical switchboard. So, what happens when you combine the passive digital truth of ERC 7827 with the active local execution of SeedTree DB? Well, you get pure physical automation. Meet the Flow X42 Cheerbot. It acts as your very own physical gonzo field journal. Tucked inside this cheerful little 3D printed collectible shell is a localized Raspberry Pi microhost. It completely bypasses complex legal contracts and centralized cloud intermediaries to act as a fully functioning robotic switchboard right there on your desk. To understand how it actually moves, you gotta look at the GPIO pins on that Raspberry Pi. General-purpose input-output pins are these tiny metal prongs that serve as the literal physical nervous system of the hardware. They are the exact threshold where pure mathematical digital logic is flawlessly translated into raw, real-world electrical shocks. Let's move to and see how this builds into an exact, deterministic root-to-leaf pipeline. Step 1. The on-chain ERC 7827 protocol registers a verified state change, kinda like a digital tip or payment. Step 2. The local SeedTree DB architecture inside the Cheerbot queries that LIFO index 0 to confirm the flawless mathematical truth. Step 3. Upon verification, the Raspberry Pi instantly triggers those GPIO pins. Math becomes a literal electrical signal that spins a motor or dispenses an item. Section 6. Bridging worlds. Digital to physical. Let's zoom out a bit and look at the massive philosophical shift this architecture represents for you, whether you're a developer or just an enthusiast. This quote beautifully captures what the source material calls the semiotic bridge. It states, "The human pilot applies the intent, but the agent cell executes the sweat." By combining global LIFO anchors with local SeedTree execution, we have literally created a system that flawlessly translates your messy human desire into strict, uncompromising, and deterministic machine execution. This is the ultimate realization of leaf node logistics. Instead of being a digital tenant renting processing power from a massive centralized cloud empire, you secure the physical hardware you actually own. You publish your unalterable intent on-chain, and you execute it locally, privately, and blisteringly fast. You are no longer just a user. You become the sovereign pilot of your own machine. I want to leave you with this final, provocative thought to chew on. We have just mapped a flawless, deterministic bridge from a global digital ledger directly to localized physical hardware. If pure math can now directly trigger physical reality without any corporate middleman, who truly controls the switchboard on your desk? Thanks so much for joining me on this explainer. Keep asking the hard questions, and I'll see you next time.